This is the video on lesson 2 from the grade 7 module 4 book. This lesson starts on page 6. So in this one, we are continuing on with percent, and we are talking about how it is a part of a whole. Now we know percent means that it's the part out of 100 as a whole, but we don't always have a 100 as a whole. But we can still connect that to percent. So we're going to check out how that is done. To do that, we need a formula. So a formula to connect parts, wholes, and percents is that the part can be found by taking the percent and multiplying it by the whole. Now there is something else we have to think about with percent. We know 3 different ways to represent percent. The easiest way to use this formula is when you have percent as a decimal, or it could be a fraction, since we also know how to type in fractions into the calculator. But decimals are the quickest way to go. All right, so going on with this, let's look at the opening exercise. It says, what is the whole unit in each scenario? So in this one, we're not actually going to be answering the questions they give us. Like, we're not actually going to find out what percent 15 is of 90. We're just identifying the whole unit. So the whole unit, I'll go ahead, I'll put that in green here. If we're going to start using this, formula here, we have to know what numbers to plug into what part, meaning what number to put in for the part, what number to put in for the percent, and what number to put in for the whole. So in this opening exercise, that's all we're doing, is identifying the whole unit. So the trick to identifying the whole unit is that the whole unit is usually after the word of. Now, not all the time. Sometimes they use a different word, but most of the time in 7th grade, the whole comes after the word of. Let's take a look in this first part here. So the first part, the question reads, 15 is what percent of, there's that word of, 90. So the whole unit in this case is 90. And we can keep going. What number is 10% of 56? There's that word of. They want to know what number is 10% of 56. So 56 is our whole. The part, or not 59, 56. The part is whatever 10% of that is. This one, 90% of a number is 180. Here's the word of. I know that 180 is technically after it, but it's not directly after the word of. It's more further away from it. The word directly after the word of is this a number. And the same kind of theme holds true, where it's usually after the word of. Right here, if this was a number, it would be the whole, but we don't know the number. So we'll just say the whole unit is a number. And sometimes that'll happen. You'll have to use that formula to find the unknown. The unknown could be the part, the percent, or the whole. All right, moving on. A bag of candy contains 300 pieces, and 25% of the pieces in the bag are red. So this one's a little different. The whole in this case is all of the pieces of candy in the bag. So I know that it says 25% of is right here, but they already gave us the whole. So the rule doesn't actually apply in this case. The bag of candy contains 300 total, so 300 is the whole. 70% of the students earned a B on the test. So what is the whole number in this? 70% represents the students that earned a B on the test. The whole is all of the students taking the test. So there we go, all the students taking the test. And then this last one, the 20 girls in the class represented 55% of the students in the class. So the rule works there, or the shortcut works there. the whole represents all the students in the class. And there we go. Okay, so we got A done. A was just identifying the whole. B, we're going to identify all three. We're going to identify the part, the percent, and the whole. So let's start by this. We know how to find the whole, so let's go ahead and let's start by finding the whole, then we'll work from there and find the percent. So problem number one, 40% of the students on the field trip love the museum. If there are 20 students on the field trip, how many love the museum? Well, here's my first clue. It says 40% of, and it says the students on the field trip. So if I stopped right there, I wouldn't know the number, but I would know that the whole is the total students on the field trip. But we read on and we say, if there are 20 students on the field trip, so there they go, they give us the number. So 20 is the total students on the field trip. That's the whole. Now, to find the part, well, let's actually talk about the percent first. So the percent in this case, pretty simple to see. They give us the percent symbol right there. That percent is given, so we'll say 40%. Now the part is a little trickier. They don't give us a number for the parts, but they tell us what the part represents. They said 40% of the students on the field trip love the museum. So the part is just going to be the students on the field trip that love the museum. There we go. So that's what the part represents. And once we get better at doing this, we'll be able to identify what that number is. We'll be able to find out what that number is. Okay, let's head to the next problem down. So the next problem down, let's check out the whole first. So it says 40% of the students on the field trip love the museum. If 20 students love the museum, how many are on the field trip? So kind of the same, similar problem, but not the same. They give us different information. Here they said if there are 20 students on the field trip, and that was the whole, here they're saying 20 students love the museum. So that's not the whole, because the whole is kind of the same as the scenario above. The whole is the students on the field trip. So we'll put that in for the whole. So the whole is the total students, or all the students on the trip. The percent, we kind of got a similar situation. They give us 40% again. And from here, the part is the percent, well, it's the students on the trip that love the museum. They actually give us the number in this case. We see how here it's 20 students that love the museum. It doesn't say 20 students only on the field trip, it just says 20 that love the museum. So we'll put the number 20 for the part. So now the unknown from that one was the whole. Again, though, we could use that formula to find out what the whole is. Okay, here, 20 students on the field trip love the museum. If there are 40 students on the field trip, what percent love the museum? So here, it says there are 40 students on the field trip. So that's the whole, that's the total number of students. So 40 is our whole. 20 students love the museum. 20 students on the field trip love the museum. So we want to pay attention for the percentage they're looking for. It says what percent love the museum? Well, 20 is going to be the part. The percent in this case is unknown. The percent is going to be the number of students that love the museum out of the total students. So remember, percent is a part out of a whole. In that case, it talks about what the part is and it talks about what the whole is. The percent is that fraction or that ratio. All right, let's move on. So we got A done, we got B done. Let's actually get into an example here. So example, here it says visual approaches to finding a part given a percent of the whole. In Ty's math class, 20% of the students earned an A on a test. If there were 30 students in the class, how many got an A? So since we're doing this visually, I would like you to start out by creating a tape diagram. Here's what the beginning of your tape diagram is going to look like. You're going to start out making a box, all right? And this box is going to represent 100%. So from here to here represents 100%. So if we filled in the box completely, that means that we would have 100%. So going on from here, we want it to match this scenario where 20% of the students earned an A on the test. So to represent that, we'll connect percent to actual number of students in this case. I'm going to eventually fill this in, but here, this end here would represent 0 students, in this case earning an A on the test. If we filled this in completely, so if it went all the way from here to here, that would be 30 students receiving an A on the test. But that's not the case because it says that only 20% of the students earned an A on the test. So what does that look like here? So to start understand what that looks like, we're going to actually break it up, meaning break this up horizontally into 10 sections. I'm dividing that 100% by 10, so each section will represent 10%. Let's go ahead and do that real quick. I'll take my ruler. So there we go. I broke it up into 10 sections, each section representing 10%. So if it goes from here to here, that's 10%. This would be 20%, 30%, and so on. There I go. I filled it all in, 10, 20, 30, 40, 50, all the way up to the end here being 100%. All right, so we got our percentages broken up into it. Now on the top, I want you to think of this though. There are 30 students total in the class. So the whole in this case is 30 students. 100% would be all 30 students earning an A on the test, but we see how that doesn't happen. So what I want to do up here is I want to think how many does each 10%, I mean how many students does each 10% represent? To think of that, I know I broke this up into 10 spaces. 30 divided by 10 gives me 3. So I can label this as, this would be 3 students, 6, 9, I keep going, 12, 15, 18, 21, 24, 27, and then right there, 30. So let's go ahead, let's fill this in. It says 20% of the students earn an A on the test. Well, that means that this portion right here, filling in the 2 intervals there, to represent the 20%. If it says that there were 30 students in the class, how many got an A? Well, we filled in the 20%, and we just look above at the number of students, and that gives us 6. So we would say that 6 students earned an A. So we'll continue on with exercise 1. Exercise 1, we're going to do the same idea, use a tape diagram to help come up with the answer to this. In this one it says, in Ty's art class, 12% of the Flag Day art projects received a perfect score. There were 25 art projects turned in by Ty's class. How many of the art projects earned a perfect score? It says identify the whole. So to identify the whole in this case, that is going to be the total number of art projects turned in. And then the part will be the art projects that earned a perfect score. So it says right here that there were 25 art projects turned in, so 25 is the whole. I'm going to go ahead, I'm going to set up my tape diagram. So there we go. I have my tape diagram. Same deal, guys. You know, the full tape represents 100%. I broke it up into 10 portions that each represent 10%. For 10 total portions to equal 100%. The part that changes is the top. So up here, I remember I'm talking about art projects. So back here, this would be 0%. That would mean 0 art projects. Maybe I'll just put projects. And then way up here, this is the full amount, the whole in this case. And the whole is 25. So if 100% earned a perfect score, that'd mean that 25 projects earned a perfect score. But they don't say that 100% earned a perfect score. They only say that 12% earned a perfect score. So we have to figure out where 12% really stops at. I look up here. Here's 10%. 12% is going to be a little more than that, but perhaps before I get into that, maybe I should figure out what number these are getting broken up by. So I figured out, you know, I got 25 total projects. I need to split that up into 10 spaces. You can't, well, when you divide 25 by 10, you get 2.5. So what I'm going to do is instead of putting 2.5 here, we can't really have 2.5 art projects. I'll put this. I'll put 5 here. This would be 7.5. This would be 10. This would be 12.5. This would be 15. This would be 20. And then right here we get 25. 12%. 12% is a little past 10. 12% might be right about, maybe a little further than that. 12% might be right about there. But that doesn't really help us answer how many art projects earned a perfect score. We have an estimate. We know it's somewhere in between, well, this is 2.5, 2.5 and 5, but we don't know the exact number. Here's what we can do to find the exact number, though. I can look, and I know that every percent can be turned into a fraction by putting it over 100. And then the percent goes on top, so 12 goes on top. And all this fraction represents the percent. I want that to be equal, so that's 12 parts out of 100. But we didn't have 100 projects turned in. We had a whole of 25 turned in. And then this part is unknown. I don't know what number earned a perfect score. So 12 represents the percent that earned a perfect score. Up here, this has to represent the actual number of projects that earned a perfect score. Here's what I can do, though. I can figure out how did I go from 100 to 25. In this case, I would have had to use division because I'm going down from 100 down to 25. Easiest way to get there is through division. And then I would go ahead, I would say that 100 divided by, I know it's 4. You could have done 100 divided by 25. You would have got 4. So therefore, using our fact families, 100 divided by 4 equals 25. Now, since I divided the top by 4 to get 25, since this equal sign is here, I have to put the same thing for the bottom. I'm sorry, I flipped that around. The bottom was divided by 4, so the top must also be divided by 4. So that tells me that here this is 3. 12 divided by 4 is 3. So here the top represented the part, bottom represented the whole. So the whole was 25 total projects. The part that earned a perfect score was 3. So we would say 3 projects earned a perfect score.